A particle passes point P with speed 20 meters per second and moves in a straight line to point Q with uniform acceleration. In the first second of its motion after passing P, it travels 25 meters. So here I'm showing the distance travelled by the point in 1 second. So at t equals 0, the particle is here. At t equals 1, the particle is here. The particle is heading from P to Q with uniform, meaning constant acceleration. So the initial speed u is 20 meters per second. We don't know what the acceleration is. In the last 3 seconds of its motion before reaching Q, it travels 13/20ths of the distance of P to Q. So in the last 3 seconds, let's just say that the distance from this point to Q is the distance covered in the last 3 seconds of the particle's motion. And that distance is 13/20ths of PQ. It's more than half the distance from point P to point Q. Now, in particular, that means that the distance from point P to this point here can be got in terms of PQ. The total distance from P to Q is just PQ. We don't know what it is. But this distance here is PQ minus this distance, 13/20ths PQ. We can write 1 PQ as 20 over 20 PQ, so we have 20 minus 13 is 7/20ths PQ. Now, what we're not given is the time taken for the particle to go from this point here to this point here. So I'm going to say that that time is t. I'm just going to call it t. We don't know what it is. What we want to do is get the distance from P to Q. What we can do is get the acceleration of the particle. We have enough information. We have that u is 20 and the distance covered in the first leg of the journey is 25 meters and the time taken to cover that distance is 1 second. This is enough information to find the uniform acceleration. So what formula do we use? For linear motion with constant acceleration, we can connect these 4 quantities and just rearrange to get A. A is s minus ut divided by the coefficient of A, which is a half t squared. So we plug all the values for us and t into this and calculate it. So we have 5 divided by a half. That's the same as 5 times 2, which is 10. So the acceleration is 10 meters per second squared. Or we could write this as 10 meters per second squared. Same thing. Let's look at the journey from the point P to this point here. That's a distance of 7/20ths PQ. And how long does it take? Well, the time for that journey is going to be 1 plus t, or t plus 1. Add the time for this leg plus the time for this leg. The time for this intermediary leg here is t. We don't know what t is. I'm just calling it t. So that time is t plus 1. I could write down t equals t plus 1, but that looks confusing. So I just have time here. Time taken. It's t plus 1 seconds. The acceleration is 10. The initial speed is 20. We can connect all those variables using this formula. So we plug 20 in for u, t plus 1 in for the time, and 10 in for a. So that gives us 7/20ths PQ. Notice that there are 2 unknowns in this equation. The 2 unknowns are PQ and T. So this is one equation with 2 unknowns. We'd have to get a second equation with 2 unknowns. So what we will do is consider the total distance. That's PQ, and the time taken for that is going to be 1 plus t plus 3. So you see we can get a second equation and 2 unknowns, and we can solve between them to find out what t is. Anyway, let's first simplify this thing here. So we have 7/20ths PQ is 20t plus 20. A half times 10 is 5. If I square out t plus 1, I get t squared plus 2t. We get 10t plus 1 times 5. So simplifying all this, we can get 720 as PQ, but if we multiply the right hand side by 20 over 7, we can write PQ equals 100 over 7t squared plus 600 over 7t plus 500 over 7. So that's what we get by considering the journey of the point from P to this point here. What we do next is consider the journey from P all the way to Q. So for that journey, the initial speed is 20. The distance s is the distance from P to Q. We just write that as PQ. The acceleration is 10, same as before. Initial speed and acceleration are the same. What about the time? The time is 1 plus t plus 3. That's 4 plus t, or t plus 4. So we use this formula here, S, but S is PQ equals U times T as 20 times the time, which is T plus 4, plus a half times the acceleration, which is 10, times the time squared as T plus 4 squared. So you see we have another expression for PQ. And, you know, we have an expression in t equal to PQ. We have two different expressions in t equal to PQ. So we only have to equate the two expressions in t. So we put this thing here equal to this thing here and solve for t. So here we get 20t plus 80 plus we have 5 here. It's going to be 5t squared. We get 8t times 5 is 40t. 4 squared is 16. 16 times 5 is 80. So we can write this as PQ equals 5t squared. We have 20t plus 40t is 60t, and we have 80 plus 80 is 160. So we equate this expression with this expression here, because all of this here is equal to PQ, and all of this here is equal to PQ. So the two things are equal to the same thing, PQ. So that means that they're equal to each other. So I've written them down up here. This is going to be a quadratic equation. The t squared terms aren't cancelling, so we get it into the standard form, which means we want 0 on the right hand side. So I'll shift all of this to the left hand side. So we have 100 over 7, so you can use the fraction button on your calculator. 100 over 7 minus 5 as a fraction, that comes to 65 over 7 times t squared. We have 600 over 7 minus 60. That's equal to 180 over 7. And finally, we have 500 over 7 minus 160. As a fraction, that's minus 620 over 7. So to solve this, we just multiply it all by 7. So we have 65t squared plus 180 times t, it's a t in here, minus 620 equals 0. Now if you solve this, you get a solution, a positive solution, t equals 2. There are two solutions to this quadratic equation, but it's only the positive one that we're interested in. So this time here must be 2 seconds. Since each of these expressions is equal to PQ, we can plug t equals 2 into either of them. So I've plugged 2 into this expression here to get this here, and that works out to 300 meters.